Hello everyone, welcome back to CCNP Redistribution Class Lab. Guys, again this is Manny, your Cisco Juniper Master Instructor, and this lab is about CCNP redistribution. So I have drawn some diagram. So in this diagram, we are first going to try to understand the diagram. There are four routers: router 1, router 2, router 3 and router 4. Between router 1 and router 2, we have RIP version 2 running. And between router 2 and router 3, we have OSPF area 0. And between router 3 and router 4, it is running EIGRP 101. So as a first step, what we are going to do, we are going to configure RIP, OSPF, EIGRP as per the diagram, but we are not going to advertise between the routing protocols. So that means router 2 is a border router and router 3 is a border router. When you look at the diagram, router 2 is running RIP and OSPF, and router 3 is running OSPF and EIGRP. So what we are going to do, we are going to take RIP routes from R1, R2 domain and we are going to advertise to OSPF, as well as we are going to take OSPF route from R2, R3 domain and going to re-advertise back to RIP domain. Same way on router 3, we are going to take OSPF route and we are going to advertise to EIGRP side. And on router 3, we are going to take EIGRP route and we are going to advertise to OSPF side. And when you advertise routing protocol from one routing protocol to other routing protocol, it is called mutual redistribution or it is called redistribution. I strongly advise you to follow the class material to understand the concept behind redistribution. Our main focus is doing the lab. So let's try to understand here, guys. R1 has 2 loopbacks, R2 has 2 loopbacks, R3 has 2 loopbacks, R4 has 2 loopbacks. And I have configured all the IP addresses so that we can do the lab faster. Let's read through the condition one more time. Okay, build the about condition number 1, build the about topology and configure the routing protocol as per diagram. Okay, then redistribute mutually between R2 and R3. Make sure any-to-any connectivity is possible. Seed metric should be set when necessary. So that means RIP understand only hop count. So when we redistribute from OSPF to RIP, we have to put hop count. OSPF understand cost as a metric, and EIGRP understand bandwidth, delay, load, reliability, MTU. So those are the seed metric. Again, RIP seed metric is hop count, OSPF seed metric is cost, EIGRP seed metric is bandwidth, delay, load, reliability, MTU. So as a step number 2, we are going to just redistribute without any conditions and we are going to see end-to-end connectivity. Then what we are going to do, we are going to add some conditions. Look at condition number 3. When redistributing OSPF into RIP on R2, make sure router to router links are not redistributed to RIP. So that means I'm saying 172.16.23 and 172.16.34 should not go to RIP. So when I redistribute, I'm going to, there are two ways we can do. I might follow one step, your documentation follow a different step, but we are going to make sure router 1 should not see 172.16.23 and 172.16.34. I'm telling use, okay, I'm giving you some idea. Use distribute list to filter. So there is a way to filter the routes using a command called distribute list. We are going to follow that one. Then I'm saying when redistributing from RIP to OSPF on R2, set the metric to 50. This is condition number 4. So by default, the metric will be 20, but I'm asking you to set to 50. Then number 5, when redistributing OSPF into EIGRP on R3, when I want to redistribute OSPF to EIGRP, I want to make sure router to router links are not redistributed. So I'm going to use a route map or distribute list to filter that information. Then I'm saying when redistributing EIGRP to OSPF, set the metric type to type 1. That's number 6. So guys, then I'm saying check end-to-end connectivity. So let's go through each and every condition and let's do the labs, guys. And before that, we are going to configure the routing protocol. So just watch the video carefully a couple of times. My advice is to do the lab again. So guys, again, I have set up all the configurations. So I have router 1, router 2, router 3, router 4. We are going to do this one together now. So I have the links are 172.16.12, 172.16.23, 172.16.34. So as there are ways to verify if the links are good, but I'm going to type show IP interface brief, exclude unassigned. So you're going to see all the IPs. And also if you want, as I said, you can type show run pipe include inter 255. I think this is, we did the same command last time too. Be familiar with these commands, guys. Is going to help you in your further studies in CCIE or any high level studies. So right now, if I type 172.16.34.3, I'm telling it into R3. Okay, that's good. I'm on R3. Let's check here. Show run pipe include inter 255. I want to make sure R3 is configured properly. Yes, R3 is configured. And also I can type show IP interface brief, exclude unassigned to make sure all the interfaces are up. That's good. So from here, let's telnet to router 2. So 172.16.23.2, that is R2 IP address. I'm on R2. I'm going to type the same thing, show run pipe include inter 255. Basically, guys, what I'm doing, I'm checking the interface name, IP address, and subnet mask. And also I will do the same thing, show IP interface brief, exclude unassigned. From here now I want to telnet to router 1. So I cannot telnet from router 4 to router 1 because I'm not running any dynamic routing protocol right now. So 172.16.12.1. Just see, guys, I'm on R1 now. So I'm going to do the same thing, show run pipe include inter and 255. Then finally we are going to use our magic command, show IP interface brief, exclude unassigned. I'm going to exit and come all the way back to my original position, that is R4. Okay, so right now we are allowed to configure routing protocol. So I'm going to configure RIP on R1, config T, router RIP, version 2, no auto summary. So network 1.0.0.0, network 11.0.0.0, network 172.16.0.0. On R2, I'm going to configure RIP, config T, router RIP, version 2, no auto summary, network 172.16.0.0. So what's happening here, guys? What you have to understand, even though our intention is not to advertise 172.16.23 is going to go because we are advertising as 172.16. So whatever interface part of 172.16 is going to go. So that means if I go to R1 right now, guys, I'm going to see 172.16.23 as a RIP route, even though that's not my intention. So show IP route RIP. You see, this is coming because I'm advertising as 172.16. So let's look at this one later. Let's go to R2 to configure OSPF now. So router OSPF1, router ID. I'm going to hard code router ID for OSPF and RIP, then OSPF and EIGRP. So router ID, then I had advertised the network 2.2.2.0, 0.0.0.255 area 0, then network 22.22.22.0, 0.0.0.255 area 0, then finally network 172.16.23.0, 0.0.0.255 area 0. So what I did, I advertised all the R2 interfaces into OSPF. So I'm going to go to now R3. Guys, all these commands are in this PDF document, so you can have a look. Config T, router OSPF1, router ID 3.3.3.3, then network 172.16.23.0, 0.0.0.255 area 0. As soon as I type this one, I'm going to establish OSPF neighbor relationship. And also, guys, we'll type network 3.3.3.0, 0.0.0.255 255 area 0. Here area 0, and also I'll do the up arrow key, then I will change this one to 33. I was expecting a network OSPF, so I'll check here. Yeah, 172.16.23.0. R3 also has 172.16.23.0. So I didn't get a login message, but let's check. Okay, it took some time, guys. So OSPF came up. I was a bit rushed. So let's configure EIGRP on router 3. So config T, router EIGRP 101, no auto summary, then EIGRP route ID. So if you look very carefully, I'm putting the same route ID for OSPF and EIGRP is a valid configuration. Then finally network 172.16.34.0, 0.0.0.255. So R4 has 3 interfaces. I have to advertise in EIGRP. Let's go to R4. Config T, router EIGRP 101, no auto summary, EIGRP route ID 4.4.4.4. So remember, if you don't hardcode the route ID, routers automatically pick a route ID. In this case, it will pick a highest loopbacks, but it's best to hardcode the route ID. So network wise, 172.16.34.0, 0.0.0.255. Then up arrow, I'll make it as 4440 and also 444440. Right now, guys, I just simply configure. I'm not doing any mutual redistribution. Let's check the configuration of routing protocol on each and every router. Show run section router. So we know router 1 is only running RIP. Okay, it's only running RIP. Let's go to router 2. Do show run section router. It tells me I'm running OSPF and I'm running RIP, but I'm not doing any redistribution. Router 3. Do show run section router. So guys, you guys should be very familiar and just very fast in configuring these ones, guys. Just see, I'm running EIGRP and OSPF, but there is no command called redistribution command. On router 4, show run section router. Okay, so let's go and look at this particular document also, because I want to go. So this is MANIADVANTAGE, who is doing the lab right now, your master instructor. Okay, so all the commands I'm putting here. So router 1, router 2, router 3, then router 4. So what I'm saying is you can type all these commands on relevant routers to check the configuration. So let's check these show commands. So here on router 2, router 1 is running RIP. So I can only type show IP route RIP. Router 2 also I can type show IP route RIP. So it's from router 1, and also show IP OSPF neighbor, one neighbor, show IP OSPF database, and finally show IP route OSPF. If you see, I'm not going to say any EIGRP route, I'm going to see only OSPF only. If I go to router 3, I will see R2 routes and R4 routes. So router 3 is running both EIGRP and OSPF. I can type show IP EIGRP neighbor. EIGRP neighbor is up, and also I can type show IP OSPF neighbor up. Then I can type, if I want show IP route OSPF, I have my local OSPF route, and also show IP route EIGRP. So guys, the idea is I'm not sending any route. So we are going to go further into section, see what we have to do. Okay, so I'm going to do section 3 and 4 together. When redistributing OSPF to RIP, make sure router to router links are not redistributed to RIP. So now what I'm going to do, I'm going to go to router RIP. I'm going to say, please redistribute OSPF1. So that means please send the OSPF1 inside. But when you send, make sure to put the seed metric related to RIP. So RIP understand only hop count. I'm going to put a hop count of 5. And also what I'm going to do, I'm going to put a command called distribute list 21 out FA00. I'm going to deny the router to router link. So what is the router to router link? 172.16.23.0. So guys, what I'm going to do, I'm going to just keep this one because I want to make sure everyone understand this one. So what I will do, I'm going to just exactly type the command whatever we are going through right now. Okay, so router 2 is the main guy here now. Okay, config T access list 21 deny 172.16.23.0 0.0.0.255 and also deny 34.0 0.0.0.255. Then I will go to router RIP. I would say redistribute OSPF1. You have to make sure you are typing OSPF1. That's why I always type OSPF1. I'll type metric of 5. In addition to that, I will put distribute list 21 out. It is connected to R1 via FA00. So right now, guys, if I go to R1 should see. If I go to R1 should see all the route. R1 will see EI, not OSPF routes, but not the router to router link. Okay, so show IP route RIP. We want to make sure 172.16. Okay, 172.16.23 is still coming. We have to just make sure that is stopped. So clear IP route star. Show IP route RIP. So you had to wait for a while because I just cleared the RIP routing table. Okay guys, look like we have to wait for that 30 seconds update. RIP will update every 30 seconds. So there's a command called debug IP RIP. That's a very powerful command. You can type that one too. But I want to check the redistribution in the meantime. Show run section router. Okay, so what I did, I went to RIP and I'm redistributing OSPF1. So I think the route should be coming right now, any minute. Okay, show access list 21. Oh, I think it's okay on R2. I want to see access list 21. Did I do properly? Okay, because I'm not putting permit any, because if I don't put permit any, guys, so just see this is the mistake. If I type, it's a very good thing, the labs, if I type show IP access list 21 don't have a permit any. So what I'm going to do, I'm going to type config T access list 21 permit any. If I type now show IP access list, yeah, now permit any, now it will go. Before what happened, there's an implicit deny, so we have to be very careful, guys. There was an implicit deny, that's why the routes were not visible on R1. So let's go and check right now for the routes. I'm going to go to GNS and bring back my router 2. I want to bring router 1 one more time. I want to bring router 3. I want to bring router 4. Okay, so it's back to normal now. So guys, I'm going to see router 1 to make sure I see the routes right now. Show IP route. Okay, so look at this one, 172.16. So I want to specifically say show IP route rip. 172.16.23 is not there anymore. So guys, so configuration is right. So let's continue with the configurations. Then under OSPF, I want to say redistribute RIP subnet. So in OSPF, you must type subnets keyword, but as per the requirement, it says metric is 50. So let's put that one under in R2. So let's go to R2, config T, router OSPF1, redistribute RIP subnets metric 50. So I didn't deny anything. I put that one. So that means to see this configuration, I had to go to router, go to R3. I should see everything. If I type show IP route OSPF, I should see all the routes from R1 as E2 and 50. Let's check. Just see, it is coming as E2, E2, E2. These are R1 routes. That means they are redistributed route. The administrative distance is 110, but the metric is 50. Because we have to understand OE2 route, the metric never changes. If I don't put 50, or by default it goes to 20. Let's keep on continuing, guys. So we have done 2 sections. Okay, next one. When redistributing OSPF to RIP, make sure router to router links are not redistributed. So here, instead of using, I want to use a different command here, guys. So let's see what I'm doing here. Okay, I want to change this access list. So there's a typo here, guys. So what I'm going to do is E2O. So I'm using a different strategy. So I had to create a route map here. In the route map saying E2O, I'm going to say match IP address 34. So that means, no, this is right, match IP address 34. So what I'm going to do, I'm going to create a access list saying don't allow this subnet, don't allow this subnet. So this is the subnet, this is supposed to be 12, and this one supposed to be 23. So 12 is nothing but link between 1 and 2, 23. So this 34 I'm going to change to 12, guys. Okay, so let's do this one. So I have to go to router 3. As I said, access list 34 deny 172.16.12.0 0.0.0.255, and also I will say 23 because 34 is my local link. 23. Then I will say permit any. Then I'm going to create a route map. In the route map, I'm going to say route map E2O, everything is capital, permit 10, match IP address 34. So what is the IP address 34 says? Don't send these to router 1 to router 2 links, and don't send router 2 to router 3 links. That's a requirement. Everything else send, that's permit any mean. That now I'm going to go to router EIGRP. So router EIGRP 101 redistribute OSPF1 metric. So as a best practice, I always type this metric, but you can come up with own standard 1500 1 251 1500. But it should be supposed to match to a condition. The condition is called route map. The name of the condition is E2O. So that means I gave a name going from EIGRP to OSPF. So when the route goes from EIGRP to OSPF, I want to make when the redistribution happen, when I redistribute OSPF route into EIGRP, I want to give this seed metric, but I want to also make to match to this condition. So that means, guys, if I go to router 4, I will see everything, even R1 route, but I'm not supposed to see the link. So that's my main goal. Let's see. Show IP route EIGRP. Just see, guys, I'm not seeing anything with 172.23, but I'm seeing router 1 routes, 111, 11, 11, 11. So our condition is working. So next one is, I'm saying when redistributing EIGRP to OSPF, everything should go as E1 because by default it's E2. So I'm going to type this command on router 3. On router 3, I have to go to now OSPF. So router OSPF 1, redistribute EIGRP 101. I have to type subnets keyword. Then I'm going to type metric type 1. So that means, so guys, the lab is almost done right now. So try to understand so only changes I did was I changed this 34 to 12. That's the only change I did. Okay, so now checking end-to-end connectivity. Okay, so let's go and verify the routing table one more time. Let's go to router 1 and type show IP route RIP. I should not see links. I should not see anything with 172.16, but I am seeing 2 loop back from router 3, 2 loop back from router 2, and 2 loop back from router 4. Same way, if I go to router 4, I should not see 172.16 route, but I should see router 1 loop backs, router 2's loop back, router 3 loop backs. You can ask, where is router 4 loop back? Router 4 loop backs are connected. If I type show IP route connected, you will be seeing router 4 loop backs. Same thing on router 1. If I type show IP route connected, I will see router 1 loop backs. And we never said the middle routers, that means R2 and R3 should not see connected route, that means links. So if I type show IP route pipe include 172.16, I think R2 has no restriction. Yeah, R2 sees everything. R2 sees 12 and 23 is connected route, 34 is coming from OE1. Same way, R3 also same thing. If I type show IP route pipe include 172.16, I should see all the 3 connected networks. Here 172.16, 34, 23, 12. So guys, always remember, whenever you go to routing table to analyze the table, so you can type command show IP route. It's going to display even connected and RIP routes both. But if I type, you can also type show IP route RIP to see the RIP route, and also you can type show IP route connected to see connected route. Same thing, if I go to R2 for example, R2 is part of RIP and OSPF, I can type show IP route RIP, then show IP route OSPF, then I can type show IP route connected. If I want to see everything, I can type just show IP route. So I'm seeing everything, RIP, connected. If I want to see EIGRP route, I can either go to R3 and R4, because we have to always remember the diagram. Diagram is our Bible. So always before you do a lab, take a snapshot or draw this diagram. You can put a pause and also write, if you don't have the condition, write down the conditions. And I'm going to go slowly. If you want, you can just take a snapshot. This router 3, router 4, then condition number 3 and 4. Just see, very easy configuration. Condition number 5 and 6. So again, here instead of 34, you should be putting 12. That's the only changes required here. Guys, now we are going to check. So check the end-to-end connectivity. Basically, what I am saying. So R1 cannot ping 444, okay, but 111 can ping 444. So that means if I do normal ping from R1, let's see what's happening from R1. If I type show IP route, I'm seeing 4.4.4.4. I'm seeing. So basically, if I try to ping 4.4.4.4, we think it's going to work, but it's not going to work. So there is a reason when you do a ping from R1. So if I'll go back to the diagram one more time. If I do a ping from router 1 to loopback 4 of router 4. The routes are there. So when the packet goes, the packet is going to take the IP address of the source interface. So the interface IP address of R1FA00 is 172.16.12.1. So packet will go all the way to R4, but R4, since it don't know how to come back to 172.16.12.1 because we stopped router to router link, R4 will drop the packet. But if I do the same thing with a source address of 111 or 11.11.11, it should work. So let's go and try that one too. So if I do ping source 1.1.1.1, it should work. Even if I do source 11.11.11.1, it should work. The same thing true from R4 also. If I do ping 1.1.1, it should not work, because when the packet goes from R4, the source IP will be 172.16.34.4, but R1 don't have that particular network in the routing table. But if I do source 4.4.4.4, or if I do source 44.44.44.4, it should work. So guys, this is a very interesting redistribution lab. Is going to give you some insight. This is the class lab, so my advice is try to do a couple of times until you get the feel of redistribution and distribute list. Follow the class material very carefully and you'll be okay in the class. Just see, I'm saying here, but when you ping from router 1 to source, ping will succeed because loopbacks you advertise into all 3 routing domains. The reason why the initial one is not working is we are denying router to router links. If the configuration is right, on R1, when I see the rip routes, I should see all the loopbacks as rip routes, except the R1 loopback. On R4, when I type show IP route EIGRP, I should see all the loopbacks as EIGRP route, except R4's own loopback. So let's do the final verification, that one too, guys. On router 1, if I type show IP route rip, I should see all the loopbacks, but not the own loopback. As I said, if you want to see the own loopback, you must type connected. Same way, if I go to R4 is running EIGRP only. Show IP route EIGRP, I'm going to see all of the loopbacks. I'm not going to see connected link. If I want to see connected link including the own loopback, I must type redistribute connected. Guys, I assume you enjoyed this particular class lab. And again, good luck in your CCNP redistribution lab. As I'm again saying, read the concepts, do the lab multiple times. This is Manny, your Cisco Juniper Master Expert Instructor. Again, good luck in your studies, guys. Thanks for watching my video.